Welcome to The Joy of Soldering, Episode 4, the OTA VCF from AI Synthesis. I'm going to start by snapping the board in two and putting in the 210 ohm resistors. Normally I would put in a bunch of resistors and then solder them all at once, but for the purposes of this demo, I'm going to be putting them in one by one and showing you where they all go. I think I was soldering some SMD or something prior to this. So my iron needed quite a bit of retinning. Now I'll move on to the 10K resistors. There's 7 of them on the bottom board. Every once in a while the spacing gets a little off, so I'll use the pliers to pull the leads and make them nice and tight. There's one 1K resistor at R25 on the bottom board. And four 220 ohm resistors. There's one 470 ohm resistor. And two 4.7K resistors. There's one 470K resistor. and then three 47K resistors, one on the bottom board and then two on the top board. There are five 100K resistors, three on the top board and two on the bottom board. We're all done with resistors, so we're going to move on to capacitors. There are 4.1 UF capacitors on the bottom board. They're all in the power section and are all just part of basic power protection circuitry. Now we're going to do the 4.7 NF capacitor. These tend to be a little bit too tall to fit on the other side of the PCB, so we fit them to the back side of the bottom PCB. There's so many components on both sides of this board that making it through hole causes a little bit of a puzzle box, but this method allows fairly easy soldering of all components. Then we move on to the IC sockets to make sure that we can get them in and that they don't interfere with other parts that we're trying to solder and vice versa. I'm using a micro flathead to bend the pins in on the other side of the board. You want to make sure that you match the orientation that's on the silk screen. That will help you make sure that you don't mess up the orientation for the IC chips. If you do mess those up, you will probably get a short, and if you power on without testing it, you will probably get a bad chip and some of that magic smoke. There's one 14-pin socket and one 16-pin socket, so you don't want to get those mixed up either, although it's rather hard to fit the 16-pin into the 14-pin slot. Now we do the Eurorack boxed header. You want to make sure that the notch is facing up, away from the rest of the parts. That will ensure that your Eurorack cable only goes in one way. This is normally a very easy thing to solder. For some reason in this video, I have a very, very hard time soldering it, but it should lay essentially flat even with the 4.7 NF capacitor in there. But oftentimes when I go to video these builds, I just have ridiculous problems because I'm on camera, I suppose. When I first do this, I actually got it not quite straight on, so I put the iron onto the pin and heated it up while pressing the header flat, and that ensures that it reflowed with the boxed header nice and flat against the PCB. Now to the PCB headers. There are two 6-pin headers that sandwich the two PCB boards together. I like to put them in first without soldering them at all, and then go ahead and put them together, and then use them stacked together as a nice way to hold them together. You can put them male or female on either side, mix them up if you want. This is just the way I tend to do it. And then, of course, because I'm filming myself again, something that usually takes 2 seconds, I fumble all over the place. One area you do want to be careful with these headers is making sure that you don't accidentally get any solder between one pin and another. They can be slightly trickier to solder than other items just because there's so much metal connecting them together. There's not only the big piece of metal that makes up the pin that you're soldering in, there's also the fact that it's when you have them connected, as I'm going to do, you have that metal then connecting with another piece of metal, the other side of the header on the other PCB. So there's a lot of heat dissipation that can happen. So it can take just a little bit longer. It's not, any more difficult, it just takes more time to get the solder to flow really nicely. And you just want to make sure that you don't get any transfer between either sides of the pins. The only time I had an issue when I was building the test models and making, just the tons of versions that I make before I put the market out was the filter cutoff not working because I had accidentally created small solder bridges between the header pins. So just make sure you don't do that. Now we'll do the 3 10UF polarized electrolytic capacitors on the bottom board. 2 of these are just for power protection, and the other one is for the circuit. Just make sure you have the orientation correct per the PCB. And you can use the pictures on the website or here if you need help. Now we'll do the two red LEDs. These are actually the diodes in the resonance signal that give it its great squelchy tone, and they light up as the resonance is increased in the circuit. You can watch it as you're testing, which is kind of fun. They could probably, I think, go in either way as long as they don't match, but best to just match the PCB up either way. It can be sometimes hard to see which side of the LED is flat in real life versus what's shown on the PCB. So just remember that the shorter leg is the flat side, and you'll be just fine. We do the LEDs before the trimmers because you can get in the way of soldering in the LED if you do the trimmers first. But at this point, it's a good time to do those. The rectangular one is a multi-turn trimmer. That's for fine-tuning the attenuator on the front panel. And then the two square ones are single turn ones because they're really more just for flavor and taste. One controls the resonance drive, the amount of gain that goes to the resonance versus the passed signal, be that high or low depending on the mode you're in. And then the other one tunes the cutoff knob. Essentially the cutoff knob, like in I think pretty much all voltage controlled filters, goes between the negative voltage and the positive voltage on either side, and then you're just tuning that. So this kind of allows you to have a finer tune of that to kind of offset whatever the pot would just be doing on its own, to give you either more low pass range in low pass mode or more high pass range in high pass mode. With the thin legs of these trimmers, it can be helpful sometimes to put the solder on to the leg and then go back and use the iron to reflow it into place. Now we'll do the two 1NF capacitors. These should be able to easily fit on the top side of the bottom board where the screen is with no issue. They'll be almost tall enough to hit the other side of the PCB when you put the top PCB on, but there should still be plenty of headroom. If you're not able to get that amount of headroom, these are non-polarized capacitors, so you can always solder them to the rear side of the bottom PCB if you're out of space. I usually put them in, and then we'll put the top panel facing PCB on just to make sure that they do fit, and then solder them in at that point. Now we can add the SPDT switch. This switch is a setting that controls how much gain the resonant circuit gets compared to the passed circuit. So there's a quote-unquote normal mode and a quote-unquote wild or crazy mode. It does more change than the trimmer. Even if you plan on doing the mod, I still suggest soldering it in. There's no wiring to my builds because typically if you made a mistake, it's usually in the wiring. So without wiring, you can look at your build and say, well, it's either the component placement or the soldering, but it's got to be one of the two, nothing else, right? Unless the 1 in a million chance you got a bad chip or something, which in my 10 years has only happened once. It's a really easy part to desolder. So even if you're planning on modding it, I would still go ahead and put it in there on the back just so you can test your circuit and know that the switch is not the cause of your issues. And then to finish up the bottom side of the board, we'll do the two N3906 transistors. Just make sure you match the orientation on the PCB, and otherwise these go in just fine. You will want to use a little bit of care and make sure that you don't heat them for too long, but they're fairly resilient, and as long as you're soldering them as normal, then you shouldn't have any issues with them. Now that we're done with soldering all the components on the bottom board, we'll go ahead and insert the ICs. Again, just mind the orientation. If you get the orientation wrong, they will short and blow up. So you just want to get that part right, and then just get them in nice and tight, and then we can move on to the top board. We're almost done. Now we'll do the potentiometers. There is an error on the silk screen for the A100K for the CV trim. It should be a B100K, so please do mind that. But of course, the first thing is always to unscrew the nut in the washer and use diagonal cutters to snip off those little nubs in order to get them sitting flat. Technically, the circuit will work with an A100K potentiometer in the CV attenuator location, but if you do that, then instead of your 0 location being 12 o'clock for no CV in on either the plus or minus side, it will be somewhere near 2 o'clock, and you'll have a weird curve between negative and positive. So the kits come with the B100K pot, and it's been corrected in the BOM. First put in that B100K pot, and then maybe do the frequency pot, and then just do the A100K pots that are left over for the resonance and the audio in. Now we add in the DP-DT switch. It's a simple switch, so polarization doesn't matter, and it'll fit in snugly, which is good. That's what we want. Ensures good contact. So just push it in, and then you're ready to solder it. Now we do the jacks. I like to go ahead and put them in and then just do the ground lugs on the top side, really just tacking them in so they sit nice and flat. With these particular jack styles, it can be a little bit difficult to get them to sit flat if you just solder them on the bottom. You'll see I took the bottom two out there so that I'd have easier access to the ground lugs for the top two. And then I'll put those in afterwards and tack them in. I'm still going to reflow those ground joints on the other side to make sure I have good contact, but this is just to make sure they sit flat. Now that we're done, we're going to fit the two boards together and then move on to our testing and calibration. There's going to be a separate video for that. Thanks for watching and happy building.